Well, we've added a few more networks into our company. Really didn't do a hub and spoke, more or less a full mesh, almost a full mesh. A full mesh, I would have had one more link between branch B and C. But so I've added a branch B that needs to be completely configured. And the goal is to be able to use OSPF to get from all of the networks that you see here from one to the other. So on the north side, what I've got here is 192.168.1 network. On the south side, I've added a 192.168.2 network. But technically speaking, I have added 4 more networks. The link between branch A and C, the link between branch A and B, between B and headquarters, and C and headquarters are also going to be networks that we will have to advertise through the OSPF routing protocol. By the time we're done, our goal is that we can ping from any one PC to any other PC going through these networks. And don't forget that technically there are 3 networks over here on branch A's Ethernet because we are using VLANs with different networks for each VLAN. So it should hopefully make for a very good sized single area OSPF deployment. Unfortunately, we're going to have to go and do a little housework. And I thought it makes for a great review. Starting with branch A, getting into the configuration here, and I changed its name. Let's exit here for a second. Show IP route. So here's what we need to get rid of. The static routes. We're going to be doing everything through a dynamic routing protocol, so we should not be needing static routes. So we'll go to the configure terminal and say no IP route 0000, and again the other 000, and its gateway, it looks like, was 209.165.201.2. Okay, do show IP route, make sure it's gone. All right, so we only have directly connected interfaces, and we have 2 other interfaces that aren't showing up because they haven't yet been configured. But I just want to clean up the static routes. Headquarters has a few more static routes because of the other subnets. So let's come over here and log in. Get into the user or privilege exec. And before we go there, show IP route. And yes, 3 static routes. And we need to get rid of all of those. In fact, it actually looks like I misconfigured one. I'm glad we never tested the one to the 10.1.1 network. So config T, no IP route. In this case, let's get rid of the bad one, 10.1.1.0. And then 255, 255, 255.0 with the next hop that incorrectly said 209.165.201.11. Up arrow time, change that 11 to a 1, and put the 0 by the 10. Up arrow time again. This time get rid of the 1 for the 10, make it a 20. And now let's do a show IP route. And just make sure, do show IP route. I still get caught with that. All right, we have our 2 directly connected interfaces. Now, in part of our course, of course, we talked about IPs, subnets, trying to conserve subnets. And so the links between the branches and the headquarters, the ones that are diagonal here, I'm going to basically put them into a /30 subnet so that there's only 2 valid addresses that can be used in the actual address scheme. So I'm going to take and basically start with the network 172.16.1.0/30. And by doing that, it'll break it up in the way in which we create these addresses. So if you think about what that address is going to look like with a 0/30, let's bring up an extra little quick program for you, just so you can see what I'm talking about. 172.16.1.0 with a /30. So you think about how that is in binary. That means the 0 would be the first network, and there's only 2 valid hosts that would be on that. That would be 172.16.1.1 would be the first valid host address, and then 172.16.1.2 would be the next one. And The 1.3 would be what? That would be the, so let's just label it here, just to make sure you understand and remember. That's the network address, the 2 usable host addresses, and the next part of it would be the, I'll put it down here, 172.16.1.3 would technically be the broadcast address. So then what would be the next usable address space? 172.16.1. I hope you're all with me. 4/30. And again, that's the next network address. And it's going to continue to kind of increment that way as we're basically counting upwards from 0 through 4. So it'll always go in those little ranges of 4. And that's an important aspect to remember as well, as far as how we set that up. So we're going to do that in making the configurations, and I'm not going to continue to repeat this little process. I just hope that you remember there's only 2 valid addresses because I've only got 2 bits for my host. If we need to come back to it, I'll bring it back so you can see it again. So we might as well start with branch A. Branch A is using the, and I tried to match these up. The 1.0 fast Ethernet is connected to the 1.0 fast Ethernet on branch B. I'm just trying to line up the port numbers to make it easy to remember how to configure those. And maybe I'll just bring it up one link at a time so we can watch each of these links come alive as we go. So I'll start off with branch A. And in this case, as I said, we're connecting the 1/0s on the 2 sides between those. So let's go into the interface F1/0, and from here, IP address 172.16.1. Remember, 0 is the network address, so 1 was the one that we needed. Can you remember what a 32-bit subnet mask looks like? It's 252. Remember, the last 2 bits would be zeros, and they fall in the 1s column and the 2s column, so that should be the right address. But we also know, as routers are, that unless you've done a no shutdown, that the interface would be dead. All right, so I've got that one set up. Let's do a write just to save it, and we'll move off to the next branch B. Now we've done no configuration at all on branch B. So, and I'm not going to take you through the security part of this just yet, but I do want to at least have the host name say branch B. All right, so now we've got that set up. Now we actually have to also configure, while we're on branch B, the network, the interface up here for the 192.168.1.0. Let me minimize this window a little bit. That's because we are going to advertise this as well, and that's on the 0.1 interface. So let me bring this back into view. So we got at least these first 2 interfaces that we're going to do. Let's go to the interface F. As I said before, we'll make this interface between the 2 branch routers come up first. So we'll go to the interface configuration, IP address 172.16.1. The next available address is a 2 with that 32-bit subnet mask and a no shutdown. All right. While we're here, we said we're going to take care of the 0.1, not the 1.0, the 0.1 address for this connection to the switch. So IP address is 192.168.1.1 with the regular 24-bit mask and a no shutdown. All right, let's take a look and see, and let's do a write command, and let's take a look and see if we're getting our interfaces to come back up. And the switch is the one that's being a little slow again. It's usually slow only because it's doing spanning tree, making sure there's not a switch connected to it. But I see that our connection between these 2 have come up, and we can verify that by just doing a simple ping. So let's do an end, and from here we're going to do ping 172.16.1.1. Make sure that we actually have that connection, and we do. We're able to hit the branch A router. That's perfect. Show CDP neighbor. See if we see that neighbor, and we do. In fact, we see the switch now, so that tells me the interface on the switch is up. We do have a host out there on that 192 address, which is the 192.168.1.100, and we can hit that as well. So it looks like we're almost done with the branch B configuration, because there's only one more interface to configure, and that's between branch B and headquarters. So, all right, so we said, remember, the next network address was 172.168.1.4. And again, I guess I'll type these out as we go through this. The first address in that space is a 5. The next address in that space is a 6. The next address in that space is a 7, but we said that was the broadcast address. You'll notice the pattern that each network or subnet is going up by a value of 4. That's basically the 2 bits, 2 to the second power. All right, so, and then we'll type out what the next address would be as we go on, which would be 1.8 again /30. And to remember, even though you don't see a 0 in there on the decimal, if you looked at the last 2 bits, they would be all 0, so that's the network address that would be going on the next, after this one set. So now we're going to use the 4 network. So we'll go back to branch B, and we'll go back into the configuration. Oh, and which interfaces are we using? The way I've wired it up is that I'm connecting the 1.1 on branch B to the 1.1 on the headquarters. Again, I just like matching up those numbers to remember the interface numbers, just to make it easy to remember how I'm setting it up and which is being configured. And also while I'm here, line console 0 logging synchronous. So when I go to verify everything, that I've got it all taken care of. Okay, so interface F11, again IP address 172.16.1 dot. Remember, first address in this space with a 4 starts with a 5. Again, the 32-bit subnet mask and the no shutdown command. All right, so that side wants to work and cooperate. Let's do a write to save that. And now headquarters. Oh, headquarters looks like its interface wants to already come up and be online. It says the 1.1 interface is already ready to go. Let's take a look at what that interface has. If it has a configuration, let's do show IP interface brief. And 1.1, well, it's not administratively shut down, but it is also not assigned an IP address. Okay, let's get into that interface F11 and IP address. Again, 172.16.1. All right, so we just gave 5 out to the first one, so this will be 6. And I don't need to do the no shutdown, obviously, because that interface was already up. But we'll save that configuration. All right, so it looks like we have so far so good on the connectivity. Let's test it. Let's see if we can ping the .5. So I would need to stay in this configuration mode anyway, so we'll do a do command, do ping 172.16.1.5. See if we actually can hit it. And we did. So far so good. Now, could I hit the other one, the 1.1? That was between this router and the branch A router. The answer is no, because we don't have any routes. That's too far away. So you can see that it's timing out. All right, so we can't hit it yet. All right, let's minimize this out of the way. Between headquarters and the branch C, here I matched up the 1.0 interfaces. Again, just because it's more convenient to remember as I'm doing these configurations. And we need to go and make sure that we know the next set of address ranges. So the network is 8, and that means the first address is a 9. The next available address is 10, and 172.16.1.11, again, is the broadcast. That means that we're only going to have one other network to configure, which is going to start with a 12. And that's going to be the network address for the last of our links. And then we'll figure out what those addresses are for us when we get to those next links. All right, so back to this headquarters router. So interface here we said was going to be fast Ethernet 1/0. IP address 172.16.1. All right, so what did we say the first one was going to be? We've already done, all right, go back to this pad. We've already done the 4 network, and we're now on the 8 network, and that means the first address is a 9. Just to show you something here, what if I tried to put this on dot 4? Let's see, so 4 or 5. If I try to put it on 6. If I tried to do that command, and let me put the subnet in here. That overlaps with another interface that is in the same network. In routers, you cannot have 2 interfaces that are in the same subnet. That's not what routers do. So just as long as you realize that when you're working with these kind of addresses and you're thinking, oh, this is, what if I put it in the wrong subnet? Well, if it's not in a already used subnet, then you would just have a misconfiguration. But at least you get the warning if you have 2 interfaces in the same subnet. All right, and then no shutdown. And let's write those configurations. And we have one more now router to configure, branch C. And this one is also one that was not been used. So let's go to enable, config T. And while I'm here, line console 0, logging synchronous, just to make my life easy. And now we'll exit back to global config. All right, it's fast Ethernet 1.0 is connected to the headquarters. That's what we saw. So interface F10. IP address is 172.16.1. So what did we just use? We just used a 9, so this one's 10. And no shutdown. Now, like the router on the north, this one's connected with its fast Ethernet 0.1 to a 192.168.2 network. So we want to configure that as well. So let's go to the interface F01 and IP address 192.168.2. Oops, it's the gateway, and it's just using a regular 24-bit mask. No shutdown. All right, we'll test those out here in a second. The first interface that we configured with the .10, the 1/0 interface, should be up. And we'll do a ping to make sure we can hit the headquarters interface, which is at 1.9. All right, and that successfully worked. How about the switch? Has it decided that spanning tree is not there yet? No, not quite. All right, well, while that's working, and before I move on to the next interface, at least let's look at the next set of addresses. So 1.13 is the first address. 14 would be the next one. And 15 would be that broadcast address. All right, and that's the last one we have to configure. At least we don't have to keep doing this over and over. And it's sometimes nice if you just have it typed out and mapped out so you can remember what these ranges are. So let's go and do that. And, back to branch C. Let's go ahead and see if we can real quick make the connection to the PC in there. Do ping 192.168.2.100. All right, so we got there just fine. All right, what about this interface link? Again, I matched them up, the FA11 to 11, so that we have easier configurations, hopefully, anyway. So we'll come over here to branch C. And, we also need to, let's exit. Let's make the host name branch C. All right, now we'll go to the interface F1/1 and IP address 172.16.1 dot. Oh, what did we say? See, my memory is failing me, getting older. 13. Looks like we're going to be 13. And a no shutdown. All right, we're almost there. We have to go back to that first branch router, branch A. Oh, it's got the fast 1.1 already saying that it's up. Let's do show IP interface brief and see if it's been configured with an address. Nope, so 1.1 is still unassigned, so we need to go and take care of that. IP address 72.16.1 dot, I think this was 15. Or was it 14? See, again, my memory is leaving me. That's why it's good. Yeah, it's 14. I was thinking 15 sounded like the broadcast address, since the next network would have been 16. All right. Oh, by the way, if you do backspace and you find your cursor in the middle of a line, you don't have to worry. If you hit the enter, it's not a word processor. It just means parse and execute that. And I think I don't need to do a no shutdown, but we'll do it anyway. So I think we now have all of the connections between all of the routers. And I see lots and lots of green lights. That's a good sign. But like I said, we have no routing protocols whatsoever. No way for these devices to be able to communicate from one to the other. So we're going to start off easily with just working on these first three. And let me tell you why I'm going to do that, because this one has 3 subnets over here, and I kind of like to be the big ending to our OSPF to get all that reachability. But we are going to at least connect, first of all, branch C and headquarters with OSPF. And when we do, we're going to see if we can ping from this PC on the 192.168.200 to the PC over at 10.2.2.100, or even 101, whichever ones we want, or the server. We're just going to make sure first bringing these 2 routers on as neighbors in OSPF. So we have to start with one of them. I guess I'll start with branch C. I don't remember if I've done any saves to my changes, so I'm going to do that save. And I'm going to go back to the global config. Okay, as far as the processes go, the processes do not have to match when you are configuring OSPF. I think I've told you that before. So I'm going to purposely use different process IDs between headquarters and this this particular router. So router OSPF, there it's asking for a process ID. And I'm going to type in 50 as my process ID. Remember, it's an inconsequential number. It just means that I have OSPF running one time. So what are the commands? You remember what we have to do. We know that we're going to use all area 0. We're doing a single area OSPF. And we could, if we wanted to, set a router ID. In fact, in order to have a router ID, we need to have a loopback interface. And we haven't actually configured a loopback interface. Well, we don't need one, but it would make sense to have one. So since this is C, I'm going to actually set the router ID. That would be, headquarters would be 1, A would be 2, B would be 3, so this would be router ID of 4. And remember, we just said it has to look like an IP address. So there's the router ID, no other options. And I know it doesn't look like an IP. Well, it looks like the format of an IP, but it's just the name that I'm using. The next thing I have to do is include the network command that would cover the interfaces that I want to have running. And we'll show you again with the do show IP interface brief what we're going to have to do. We need a network command that would recognize this interface that's on the 192.168.2 network. And we need another network command that recognizes each of these other 2. Now, because we're using a wildcard mask, I can use one network command, just one, to cover both of these. And I'm going to show you how to do that. So I don't have to go and enable it specifically for each of these networks. So I'm going to use 2 network commands. The network command is also where I assign the areas. So the command is network 192.168.2.0, my wildcard mask. Now, I could have put this specific address on there if I wanted to, but again, the wildcard mask would actually cover any interface that's in 192.168.2. Area 0. That should be all I need for that first interface. The next one, network command. Now, even though I am using a 30-bit mask, on these, I don't need to have a 30-bit mask on my wildcard. So here, 255, 255. So what I'm saying is the first two, 172.16, have to match. That matches these interfaces. The next two don't have to be matching at all. Area 0. So just like that, I have OSPF running on all three interfaces. Let's do a write command. And I'm going to get back into the exec mode. And we're going to do a show IP route. Do you expect to see any OSPF routes? And the answer should be no, because we haven't got any other routers configured yet to be our neighbors. If I do a show IP protocols, that I do expect to see that I have OSPF running. And that's OSPF process 50. There's my router ID that I configured. The maximum paths, we haven't talked a lot about the in-depth, but if there are 4 or less routes to the same destination, all 4 would be used if their cost is the same. All right, so we are the only routing information source. We haven't seen any other routers. Otherwise, we'd see the router IDs saying that they're teaching us information. And so what's one of the other commands we have? The show IP OSPF interface. Let's not go quite that in depth. Interface. Let's do. Well, we'll go ahead and just do the full thing. So 01, that's the one on the 192.168 network. 10 is included. Hit the space bar. And 11 is being included because my network command with the wildcard mask covered both of them with the IP address range. All right, now that we've got that going, headquarters time. Now, headquarters has an extra interface between the original branch and the other branches. So we have actually probably 3 network commands that we're going to have to use. Let's get into the privileged exec, show IP route. Even though my neighbor is doing OSPF, I don't expect to see OSPF routes. There are certainly no OSPF routes here. So what we're going to do is get into the global config and start off with router, OSPF. Now remember, the other process ID was 50. I'm going to just make this process ID 1. It doesn't have to match. Let's see, we had 2 interfaces. It looks like, just looking at the routing table, was directly connected, that are in the 172.16 range. But I'm going to do them last with the network command, because once I hit the enter key, they're going to start becoming neighbors real quick, and I kind of want to wait for that to happen. And then we also have that 10.2.2 network. So let's do network 10.2.2.0 and the appropriate area 0 with the appropriate wildcard mask. Network 209.165.201.0. And again, even though they're using a 27-bit mask, I can still put a 255 here. Just has to match that interface range. The problem with your wildcard mask being broader than the actual subnet is you might match extra interfaces that you did not intend to have OSPF running on. And then finally, the last one, network, the 172.16. I'll just put 00, area 0. All right, so now I have OSPF running, and look at that. We just found out about our neighbor, and that's great. So let's end, and let's do a write command to save our configurations, show IP route. What have we learned? Well, we've learned about, it looks like, 2 networks. Remember, that router has another interface going towards a different branch office, so we're learning about that network. Plus, it has that local 192.168.2 network. And let's take a look. Show IP OSPF neighbors. And we see that it is a neighbor. Oh, but what did we forget to do? We forgot to put the router ID on our system. That means now we're going to use the highest IP address of ours, of the headquarter router, which is going to be this address here as our router ID. So I forgot to do that. Let's look and see if that's actually true. Let's come down to branch C, and let's do a show IP OSPF neighbors and see if that's actually true. It certainly is, isn't it? Look at that. It used the highest address. All right, so I kind of failed in my network documentation in following what it's supposed to be. I could reset OSPF after I create the router ID. Generally, though, we don't like to do resets in the middle of production because that creates outages. But we're in a lab, so I'm going to make sure I do it right. Config T and router OSPF. Remember, in headquarters, it was using process 1. Router ID 0.0.0.1. All right. Now, notice it says, in order to take effect, because once you're a neighbor with the router ID, that's your name. And you basically have to clear the IP OSPF process and recreate your neighbors to be able to make that happen. So let's do an end. And let's go ahead and clear IP OSPF process. And reset all processes, yes. Notice the neighbor went down, but it won't take very long until that neighbor comes back to life. So there it is. It's already back. But at least now, if I go back to branch C and I do my same show OSPF neighbors, at least I see the right router ID for that neighbor. All right, so I'm a little happier. What was our test? To ping from 2.100 to the 10.2.2.100. Let's check it out. Let's bring this over here. Go to the desktop, hit the command prompt, and ping 10.2.2.100. Again, we have to probably wait a little bit for ARPs to take over their job. We'll get a couple timeouts, but there's our replies. So we've learned about our destinations now, at least on two sides of this network. Now you can kind of see why I liked trying to add a little bit extra of the complexity here to what we're doing so that you can really watch this entire process go. All right, branch B has some extra networks. So branch B has the two 172.16s, and it has a 192.168.1 that's on here. Again, because it's not running OSPF, nobody is a neighbor, even though one of the neighbors is trying to. So show IP route. We have just those directly connected networks, the two interfaces going to headquarters and branch A, and this 192.168 interface that is going off to its own network. So configure terminal, router OSPF 50, and we'll stick with that number. Oh, don't forget this time, this is branch B, so it should be number 2 for its router ID, 0.0.0.2. And now the network commands. So network 192.168.1.0 with the appropriate subnet or wildcard mask, area 0. Got to be area 0. And then the network command, again, I'm going to be a little bit, how you should say, vague about which interfaces or network command, just so I can cover both of those. Area 0. All right, I should suddenly be seeing a little message that says, hey, we are new neighbors and we're fully loaded. All right, let's do this. Let's do a write command to save what we've done here. I think I may have forgotten to do that on headquarters. Again, I just like to, if things are running well, I don't want to lose it in case, I can just do a write command from there, just to make sure I leave everything working. What does the headquarters routing table look like now? We should be learning a few more OSPF routes. And look at that, we are learning a few more OSPF routes. In fact, we now have enough routing information that I should be able to get from the bottom PC to the top PC, the ones I call south and north. And because we have the address, right? We know how to get to 192.168.2.1 and 1.1. So let's try it out. Let's go to PC4. We haven't opened this one up yet. Hit the command prompt. That's the one on the south. And wow, we're already getting the ability to ping all the way through. That's awesome. In fact, if we did a trace route there, you can see that we're going through, it looks like our gateway, headquarters, and then to the actual destination. So that looks like it's following well, it's the only path it has, but it looks like it's following it just fine. All right, so we've got a lot accomplished so far. The next thing we have to do is branch A. Branch A, that's the one I was saving for last because it has all the extra subnets. Let's go take a look and see what we have with branch A. Do show IP route. So it's got, again, all those sub-interfaces and the interfaces to B and C and the one going straight to headquarters. Let's check it out and see what we can do for setting up the OSPF. So we'll exit out of here. And router, OSPF, and again, process ID is just locally important. This should be router ID 0.0.0.1. I think I haven't duplicated any of those yet. And the network command. All right, so we'll start off with, let's do the 10 network. We have 10.1.1, 10.1.10, 10.1.20. So just like I did with the 172s, I could create a wildcard mask that's going to cover all three of those sub-interfaces. So now I've got that running. And I can do, again, kind of that broad 172.16.0.0 with a 0, 0, 255, 255, area 0. And I'm going to start getting hit with a bunch of messages that's going to tell me about all my neighbors. There's 165.201.0. And again, the mask for that one, 0, 0, 0, 255, area 0. All right, let's save those configurations. Well, if we have done this job correctly, we should now be able to have full connectivity through OSPF from one side to the others, and then we'll do a couple of commands to verify it. Let's look at PC1. PC1, we're going to do its ping, and we're going to ping that server on the other side. And, ooh, destination host unreachable. Why is that? Did we not get the route? Let's take a look at branch A. All right, so it looks like we have routes. Let's take a look and see what's in our routing table. So do show IP route. We were hoping to get to the 10.2.2 network, and I don't see the 10.2.2 network in there. So what happened with the 10.2.2 network? Let's go and look at the owner of the 10.2.2 network, which is headquarters. Show IP protocols. Well, it looks like we are saying that we want to advertise it. It looks like it's included. And, oh, guess who forgot to take care of another one of those router IDs? Well, that's all right. We'll fix that. We're missing that route. It looks like it says it wants to advertise it. Let's do, oh, no, we're in here. Let's show IP OSPF neighbors. And we do have a neighbor right over here. But something that's a little unusual here, it says X start. X start means that they're doing an exchange, and we normally would like to see it to be full. And so let's look and see if it just needs a little bit more time. No, nope, it doesn't look like it needs any more time. So that's where we can start looking at some of the configurations with our protocols to see if we have any problems. So we can certainly, on our next demonstration, get into some of the troubleshooting to see if we can figure out why we're not getting all of the route information. Again, show IP route on headquarters. Ooh, when I do the show IP route, what happened here? We're not seeing any OSPF routes. Show IP OSP, or let's see, show IP protocols. Well, it looks like we want to do this, and we just don't seem to have, well, it looks like we're learning routes, but it doesn't seem like we have any routes in our routing table. So that's going to be interesting. We'll try to come back with a second demonstration to do some troubleshooting.